Little's role in MIT's chemical engineering department comes in at several levels. He's a strong advocate for the department. He's several times on the visiting committee as a member of MIT's corporation, on the visiting committee that looks at the chemistry and chemical engineering department and how it's functioning. And he not only sells them on the idea of unit operations as a way to reorganize the curriculum, he's also the one that pushes for some better way to give chemical engineering students an acquaintance with industrial conditions. And that leads to the School of Chemical Engineering Practice that MIT creates also in the mid-1910s, also largely as a result of Little's influence. And then he goes out and has sufficient influence to bring in the first big hunk of money to finance it, $300,000 from George Eastman. One of the problems that early academic chemical engineering programs had was the disconnect between working in a chemistry laboratory and what they got into once they got out in the workplace, where instead of having, a distillation column that was 1 foot tall and handled grams, you had a distillation tower made out of metal that was 100 foot tall and handled tons of reagents. Moving from a chemistry laboratory where nobody ever questioned the cost of the reagents that you got off the shelf and the value of the product that you got out, to an industry where that was absolutely essential. And that disconnect was not something that chemists ever had to worry about. They were just going to go to work in a lab. They weren't going to worry about dollars. They didn't have to worry about scaling up. Chemical engineering students early didn't have that advantage. So institutions face the problem of how do we get our students to recognize the difference and get them some experience. There were a number of ways in the American academic system that schools tried to solve this. Plant visits, take them around, let them visit every chemical plant within a 50-mile radius. That will give them some exposure. Not much, not good exposure, but it'll give them some exposure. In other cases, they tried to incorporate chemical engineering into the engineering experiment stations that a number of colleges like Illinois and Iowa had introduced as parallels to the agricultural experiment stations. Now, that meant they would be working on problems of concern to industry with the college's equipment, often at a smaller scale, in not really intimate contact with industry, but at least they were industrial problems. In other cases, they used what's called a co-op program, introduced first in 1905 at the University of Cincinnati, became widespread in American engineering schools, where essentially a student went to school for a year or two, then worked in industry for 6 months to a year, then back at school, then back at industry. When they were in industry, they were employed by the industry under the authority of whoever was in the industry, and then they were back in the academic situation where it was the reverse, and the hope was the two would influence each other. MIT's approach was different than those three. At the practice school, students would go to experiment stations established with MIT faculty in charge. They would work there on industrial problems in the plants for typically 4 6-week periods. The problems that they would work on would be determined by the MIT faculty there, working in conjunction with the industry, but always selected with educational purposes in mind and working on real equipment rather than much smaller scale equipment like you would at an engineering experiment station. It was a unique way to do it. The students remained students the whole time. They didn't jump back and become part of the plant hierarchy. And the experience was always made to be educationally relevant, made with the education of the student in applying theory to practice in mind, something that you didn't get with a co-op.